Uh, so welcome students. So the previous lecture we stopped at the point where vanishing gradient occurred. So the context becomes too long. The recurrent neural network tends to forget the previous tokens. So what happens is that to prevent this, multiple other models were suggested. So we will not go deep into those concepts, but we'll just discuss a few. So some other models are actually called as LSTM. So LSTM is one such model which was proposed. LSTM is long-term, short-term memory. So instead of remembering everything, we'll filter out the useful information and we'll remember it. So this is a very high-level idea of the LSTM, but in concept it's a much deeper. So that's the basic idea. So we will filter out the concept and remember whichever is needed. So with this concepts, many models came into existence. So around 2014, there was a model introduced which was called a sequence to sequence model. So here, instead of a single LSTM or a RNN model, two models were introduced. So one was an encoder and the next one was called as a decoder. So two models were implemented in parallel. So idea here is that the encoder will summarize the incoming text. It will read the entire incoming text and it will feed that information to the decoder. So then the decoder will extract the information and process it. So we see the flow here, the entire input embedding will be processed through the encoder and it will get into the decoder. So then the decoder will start doing the task. So it is essentially a single model, but it's two model connected like this. But in essence, this is also a sequence to sequence model. So the problem with sequence to sequence model is that over a period of time, the previous context tends to be forgotten. So as you see here, the main problem is the bottleneck issue. So bottleneck issue is nothing but, so when you take a very long sequence and feed it to the encoder, it will shrink it into a small sentence. That is, it will try to fit everything into the last part of the encoder and then it will be fed to the decoder. So what happens is that vital information may get lost. So to prevent that, what we can do is we can introduce some other structure where instead of everything being sequential, that is one followed by other, what if we made everything go like this? For example, so what happens if everything goes parallelly? So what if each token is able to attend to each other token in parallel? So that is the idea of attention. So as you can see here, the attention is that each token can attach to every other token. For example, if this is the token in context, so if this is your query, then it can attend to all other tokens. So this will be your key value pair. So query key value. So each query will be able to attend to each other tokens information. So what happens is that even if the sentence becomes too long, the last word in the sentence, for example, if you take this now, in a conventional sequence to sequence model, what happens is that everything will flow like this. So write will only interact with now in a conventional sequence to sequence model. But if you take the uh, attention model, what happens is that right now will interact with every other token. So like this, it will interact with every other token starting from instead. So multiple interactions will be possible. So every information about every word will be available to now. So this will be useful in predicting the next token. So this was the major issue solved by attention. So with attention came a idea of transformer. So transformer is the extension of this attention mechanism. So why implement it in a sequence to sequence model. Why not implement in a parallel model? So that parallel model was called as transformer. So with that came the existence of large language model. So what were the idea of this transformer is that it was very fast training. Parallelism was very fast training enabling and infinite context window. So just this is just for what is a theoretical purpose we can say it. So there are practical limitations. And look at the parameters. The number of parameters become very large. So before transformers, we were talking about parameters in millions. But with the transformers, the parameters became in the count of billions. So such very large models were made possible to come into existence. So that's the introduction to transformer. So in the upcoming lectures, we'll discuss about large language models. Thank you.